Well, we're looking at functions. And in this example, which is over on page 48 in your textbook, we're going to be looking at drawing graphs. And so let's get some information that we're given here. And then we're going to look at making a table. We're going to determine the domain and the range of the function. We're going to write the data as a set of ordered pair. And then we're going to graph it. And we're going to determine whether the function is discrete or continuous. So we got a bird feeder, and we're told that it'll hold up to 3 quarts of seed. The feeder weighs 2.3 pounds when completely empty, and it weighs 13.4 pounds when it's full. And it says make a table that shows the bird feeder with 0, 1, 2, and 3 quarts of seed in it, weighing 2.3 pounds, 6 pounds, 9.7 pounds, and 13.4 pounds, respectively. Well, let's work on that first. So here we got a table, and our first row says it's defined as the amount of seed in quarts. Well, let's see, we're told that we can have 0 quarts. Let me change the color on that. It doesn't show up very well. 0 quarts, and we can have 1 quart and 2 quarts and 3 quarts, or up to anywhere from 0 up to 3 quarts. Now the feeder was 2.3 pounds when it was empty, so if we've got 0 amount of seed, well, then the weight of the feeder is going to be 2.3. And then at 1 quart, because we got 2.3, 6, 9.7, 13.4. So at 1 quart, the feeder is now going to weigh 6 pounds. And at 2 quarts, the feeder is going to weigh 9.7 pounds. So it looks like 1 quart is... each quart weighs 3.7 pounds. And at 3 quarts, the feeder is going to be 13.4 pounds. And so there we go. We've made our table. And when we graph this here in a moment, we're going to set this as the amount of seed is going to be our x values, and our weight is going to be our y values. So our domain then, where we're asked to determine the domain and the range, is going to correspond to the number of quarts of seed that are put into the feeder. And so we can then define our domain, and we'll use capital D. Well, that's going to equal anywhere from 0 up to 3 quarts. Because I don't have to put just a quart, right? Well, I could put a half a quart, or 1 1/3 quart, or 2 2/3 quarts, something like that. Now, our range is going to be defined as what we would have as our y values. And so the range of the weight in the feeders can be anywhere from 2.3 up to 13.4 pounds. All right, well, there we go. We defined our domain. We defined our range. And now let's do a set of ordered pair, or pairs, plural. So when I've got 0 quarts in the feeder, it's going to weigh 2.3 pounds. There's one ordered pair. When x is 0, y is 2.3. And when we got 1 quart, well, then we got 6 pounds. The feeder weighs 6 pounds. So when x is 1, y is 6. And when we've got 2 quarts in the feeder, the feeder is going to weigh 9.7 pounds. Again, when x is 2, y is going to be 9.7. And then lastly, if we got 3 quarts in the feeder, then the feeder is going to weigh 13.4 pounds. All right, so let's see. We've made a table. And we've determined the domain and the range. We've written the data as a set of ordered pair. And now we're going to jump over to a piece of software. I'm going to use a piece of software to help us graph this data. And then we'll talk about whether it's discrete or continuous. And the software that I'm going to use is GeoGebra, GeoGebra. And it's a free piece of software. I would encourage you to get it and be able to use it through your math experience. But you can also do it on a piece of graph paper, or you can just make up a graph on your own. But at any rate, let's go over here and let's graph this set of ordered pair into a graph, and then we'll discuss whether it's discrete or continuous. All right, I'm over here in GeoGebra, and you see we got a piece of graph paper up. And we're going to first plot our points, our x and y values here on this graph. And then we'll take a look at whether it's discrete or continuous. But let's get our first point in here. So we said that when x was 0, when there was no let's see, I need to define it as a point. Let me delete that first. Okay. So I'm going to select this option here as a point. So I want to put some points in here, our set of ordered pair. And so when x is 0, we said that the bird feeder, y, is going to equal 2.3 pounds. Okay, and I see that point up here on my graph. And our second point was that when x was, when we put 1 quart in, or x was 1, well, now the bird feeder is going to weigh 6 pounds. And we can see this second point here. In other words, when x is 1, y is 6. There's our ordered pair. When x is 1, y is 6. Let's get our third point in here. Let's see, when x was 2, when we put 2 quarts in, the bird feeder is going to weigh 9.7 pounds. And there's our third point showing up. So I could see when I got 2 quarts, x is 2 down here. I go up here near the top. Well, there's my point right there, and it looks to be about 9.7. It's close to 10, but above 9. And let's put our final point in here so that when x is 3, or 3 quarts is put into the feeder, it's now going to weigh 13.4 pounds. All right, so we have plotted our ordered pair on the graph. That looks like that's probably correct. All right, and now we wanted to think about, is this discrete or continuous? Now, if this is just kind of random sets of data that are not connected in any way, then it's a discrete function. But if the function can be graphed with a line or a smooth curve, then we could say it's a continuous function. And really what we're thinking about is, do we have to just have either 0, 1, 2, or 3 quarts in this? Or could we have, let's say, 2.5 quarts? Well, let's see. If we had 2.5 quarts, I'll go over here maybe to 2.5, and I go up. And probably this thing's going to weigh probably a little more than 11 pounds. And so I could, and one way I can represent this, and again in GeoGebra, now if I just had a piece of graph paper, I would just connect these dots. Now it can't weigh less than 0, and it can't weigh more than 13.4, because that's as much as it'll hold as 3 quarts. But I can go in here and I can say, you know what, I think I want to, let's go over here to the line thing, and let's get us a segment. We're going to choose a segment, and I'm going to click on point A, and I'm going to click on point D, which was when x is 3 and y is 13.4. And I can connect those dots. In other words, I can have anywhere from 0 to 1 quart in the feeder, and it's going to weigh somewhere between 2.3 and 6 pounds. And at the same time, if I put in between 1 and 2 quarts, well, that's going to weigh somewhere between, and then I can begin to see about where this is going to be. And determine if I had partial quarts. Well, let's say between 1 and 2 would be between 6 and 9.7 pounds. And if I had maybe 2.5 quarts in here, let's just go up here to the line. 2.5's running right about here. Well, I'd probably be sitting about almost 11.5 pounds, something like that. And so therefore I can say that this graph is in fact continuous, because I can have values varying on the quart side, on the x value side, between 0 and 3 quarts. And on my y-axis, which is my weight of the feeder in pounds, it can be anywhere between 2.3 and 13.4 pounds. So, hot dog, we have graphed a function.